Hey, here we go. I'm imagining you found this semi-tricky. I don't know. Are you ready? Here we go. Kids who want to email me and say they don't understand, now's the time to pay attention. Also, if you'd like to keep your seats, I need you to be quiet when it's time to be quiet. So, this is our thing. Remember, we talk about slope here, right? So that's y2 minus y1. Remember, our points are always, just to make sure we don't understand this, x comma the function when we're doing this, right? If you plug in a number, you get the value there, and then x plus h. And remember, you're plugging in x plus h for where x is, or 4x, so it looks like that. So those are 2 points. We're finding a slope between them. But every single time you do that, when you subtract the x values on the bottom, x plus h minus x, that always turns into an h. Well, that's it. Our job is to simplify that down. We're going to handle this the same way we handled all kinds of limits already. You see those square roots there. So we're going to multiply by the conjugate. So it goes like this. Right? And this is what you should have on your paper if you did this. Sometimes my h's and 2's look alike. Please let me know if you can't tell the difference. I try to be cognizant of that. So we got this going on here. Am I not okay with this? So I'm seeing you got square roots, multiply the conjugate. And I'm hoping at this point, when you multiply conjugates, it's going to unlock those square roots at the top, right? There's a squared minus b squared. So we're going to get, ready, x plus h plus 2, and here's a key thing, minus parentheses, x plus 2. If you forget those parentheses, it's not going to work out. And on the bottom, see, that's a 2 there. You got this junk. Aha. Okay? Nothing too crazy. And then all we're going to do is simplify this down. I told you, every time you do this, this is called the definition of derivative, by the way. This right here. And all that's doing, we talked about this the other day, is finding a slope formula for a function, right? You find the slope at any x value. That's called a derivative. So this is called the definition of derivative. All right? So you can see the top is going to simplify down. I hope you can see the top is going to simplify down to just an h. That's what happens. Now, if you forget those parentheses, that's not going to happen. But h should always cancel out when we do this. So quiz on Friday, if I have 2 of these, is what I'm thinking. All right, one will probably be a quadratic, and one will be like either a fraction or a square root. Like I'm telling you exactly what it's going to be. Just put some numbers in there. I'm just going to drop some random numbers in. That's what it's going to be. Square root one will look very similar to this. These h's are going to cancel, leaving me 1 up top. Once the h's cancel, that's when we remove this hole when h was 0. So now we can plug 0 in. We can see what's going on at 0. When you drop a 0 in for h, that becomes 0. So what you really get on the bottom here is square root of x plus 2 plus the square root of x plus 2. And everybody knows that's 1 over 2 square root of x plus 2. So if you got that, pat yourself on the back. Are there any questions? How are we feeling? A little bit of algebra going on a Monday morning, loving life. Half the classes in here. Okay. Yes, ma'am. So we're always having h approach 0. Okay? So remember, the whole idea here is this. We've got some curve, and we're saying we want to know the slope right here at x, right?
Yeah, like what is the f of x thing at the top? Like the directions?
That's what I'm doing right now. So for any curve at all, I'm just drawing a curve, right? At any x value, the y value is just f of x, right? We're choosing another x value, which we're saying is x plus h. We're saying it's a little bit bigger than x. We're adding h to it, okay? So some new x value, right? We're adding h to it. That's going to give me this point here. And I'm drawing them, they could be anywhere. X is any number at all. It could be anywhere on the curve. But the point here then is x plus h, comma, f of x plus h. All right, that's just 2 random points on a curve. I could choose numbers if I felt like it. If I knew what f of x was, I could find the values. Like we could do all that junk. But the slope between them is y2 minus y1 over x2 minus x1. And we did this all on Friday. That's in the video. If you haven't seen that, you can go back and watch that. I kind of went through this whole thing a little slower. But that's the slope between those 2 points. But we want the slope just at x. So we say, hey, let's let h approach 0. And what that does is it brings this point back. It makes h smaller. So instead of finding the slope between these points, it brings the point back, infinitely close, and it finds the slope just at 1 point. Okay? And that's called the derivative. Okay? So you do a little bit of algebra, this always simplifies down. So I'm telling you, when you do this, first off, the bottom is always going to be, you see this, right? This is always going to be h. Cool? It's the function in the numerator that you got to worry about simplifying. That's like where all the algebra is going to happen. Okay? So that's what that is right there on top of this paper. But that's just the slope, y2 minus y1 over x2 minus x1. That's all that ever is. Okay? So for number 2, which is x squared plus x right here, okay, that's going to look like this. That's the limit as h goes to 0. So we need f of x plus h. The function we're working with is x squared plus x, right? So x plus h plugged in is this. Cool. I'm not putting an h at the end of f of x. I'm plugging in x plus h everywhere I see an x. I'm using parentheses because I'm substituting into this function. All right. Minus f of x. That's also in parentheses, but that's just going to be this thing right here. So that's the basic setup. Am I not okay with where that came from? What's up?
Why put a square root instead of square x minus h?
All right, it's squared because our function is x squared plus x, right? So I'm rewriting that function, but everywhere I see an x, I'm putting an x plus h. Okay? You know, like that? Like, you know this. F of 3 would be 3 squared plus 3, right? That's what f of x does. Whatever's in there, squares it, adds it again. Cool? So f of x plus h, which is what is sitting right here. Again, it should be x squared, but now it's x plus h squared. That's what it is. You're rewriting the function, plugging in x plus h everywhere you see x. That's all. Okay? And then our job is just to simplify it down. So just like we saw with limits, we've been doing limits for a little bit here. If you have polynomial stuff, like this is a polynomial, you're going to expand it out, right, and cancel. We had to factor these before. With these h things, we're going to expand it out and cancel stuff out. That's what's going to happen. Okay? So we all know, this is, again, a common thing, just from algebra class, x plus h squared is x squared plus 2xh plus h squared. That right there is the same. Hold on, let's color code. Get out of here. This is the same as this. I just expanded it out, okay? Y'all see that? That's all it is. From that, we're going to subtract something. Minus x squared minus x. That's just this piece right here. And that's going to be all over h. Okay? And what I promise you is that when you do this, eventually, everything in the numerator that does not have an h has to cancel out. It's going to happen every time. You can see it happening right here. There's an x squared right here, minus an x squared right there. They go away. Goodbye, x squareds. There's an x here. There's a minus x here. They go away. Okay? How sweet is that? And everything that's left, you can see there's 3 terms left, right? Let's switch up our colors here. All the colors of the rainbow. We have 2xh, h squared, and h. That's all that's left up top. Every single one of those things has an h in it. So what you could do at this point, if you are familiar with how algebra and division works, is divide h into all 3 of those terms, and it cancels it out, and you can jump right to your answer, basically. Okay, but what you're really doing, if you want to write it out, is we're factoring an h out of the top. That looks like that. And again, I don't need to see you write this step. If you know that's going to cancel out there, that's totally fine. Okay? But we need it to become multiplication because that's how division works. Division cancels multiplication. These cross out now. So the only thing left, when you plug in 0 for h, now again, once you cross out the h's, you can plug 0 in for h. Okay? We remove the whole, now we can plug in and see where it is, and it is at 2x plus 1. Okay? And all this thing does right here, it tells me the slope of f of x. It's called the derivative. Cool? Like, so if I wanted to know the slope, so if f of x is x squared plus x, if I want to know the slope of that function at 3, it's going to be 7. The derivative is 2x plus 1. Okay? That's the slope. That's not the y value, it's the slope of the curve right there. It tells you which direction it's moving, which is an extra piece of information. The way we denote that is f prime of x, like that, equals 2x plus 1. Okay? Hello there. Java's not here? Who thinks that is not? Okay. We're good? You want to do another one? I know you do. So look what we've done so far. We've done a square root. That could be on a quiz for us. We've done a parabola, a polynomial, whatever. That could be on a quiz for us. Now we're going to do a fraction, 1/2x. Again, our goal is just to find the derivative, which is the function that tells me the slope of the original. Okay? So for 3, f of x is 1/2x, which means the derivative, by the definition, oh no, one note is stopping. Wait, is it going to work again? There we go, computer. Ready? I'm going to rewrite f of x, but everywhere I see an x, I'm putting an x plus h in parentheses. That's what that looks like. See what I did there? Very sneaky. I'm going to subtract from that f of x. That's just 1/2x. And it's all over, technically it's all over this because we're finding the slope there, right? But the x's always cancel, so you can just put an h there, friends. You can write that if you're really feeling it. I'm not too perturbed. Okay? And now we have a complex fraction. We've seen this over and over and over again. We're going to get rid of that. Okay? This h has to cancel out eventually. We got to make it happen. We're going to multiply by the little denominators. That looks like this. 2x plus 2h and 2x. I'm going to multiply. Y'all understand that 2 times x plus h here? That's just 2x plus 2h, right? I'm just distributing it in. Okay. When you multiply both of these things in here, so that's why we took our time to make sure everybody understood this. Both of these things get multiplied to here. What's left is just a 2x. Both of these things get multiplied to here. What's left in parentheses is 2x plus 2h. Any questions on what just happened on this fancy computer screen? Have we been doing this with x's the whole year up to this point? Okay. All right, you can see what's going to happen up top here, I hope. 2x minus 2x goes away. What's left is negative 2h. If you forget those parentheses up here, you're going to miss the negative there. It's not the end of the world, but, you know, it's wrong. It's minus the quantity. And then down the bottom, we got this thing, h times 2x plus 2h. What's up, Praise? How you doing, sir? Loving life, man. Changing the world today. Look at me. Shaping the future. In a pink shirt. This is my Stitch Fix happening. Thank you. I did. I always count you, Chris. But yes, I marked you out. Okay? H's cancel here. When you plug in 0 for H now, again, once H is canceled, kids, that's when you can plug in 0 for H because you've removed the hole that was in this entire weird expression. Okay? Now you plug in 0 for H, that becomes 0, and you can see this is just negative 2 over 4x squared. H is canceled, we get 2x times 2x. Yes, ma'am? Yeah, so remember we're here. This is really 2x minus 2x minus 2h. So the 2x is just canceled out. Cool? And we would be amateurs to leave it like that, and we're not amateurs, we're professional. Look at that. Boom. Okay? Doing your homework for you. Look at this. This is just so I can post this video on the paper later on so people can look at it, okay? All right, now look. Remember, we're finding the formula for the slope, okay? I'm going to run through 4 and 5 relatively quickly here just to get them, through here. If you have questions, let me know. But they're very, very similar to what we've already done. All right? So 4 is 5x squared minus 3x plus 6. Let's come down here. Cool. So this is another quadratic equation, all right, or expression at least. If we want to find the slope of it, the derivative of it, we're going to use our definition of derivative, but all that is putting x plus h everywhere I see an x. That's going to look like this. We're going to subtract off from that f of x. All over h. So again, just so we are fully aware of the power we have here of what we're doing, this whole thing right here is f of x plus h minus f of x. That's what that is, okay? And this is probably more than you've ever written for a math question before. It's not the most we will write this year. Just to give you a little foreshadowing. You all ready? X plus h squared. Again, it's not x squared plus h squared, kids. It's x squared plus 2xh plus h squared, right? You gotta FOIL it out. That's what it is. So, if you do that, I promise you, I'd like for us to be able to kind of skip a couple steps here. This is that, right? We're multiplying by 5. You all see that? So it's really 5x squared plus 10xh plus 5h squared minus 3x minus 3h plus 6. Woo, that's a lot. And at the very end we have minus, don't forget all this junk is back here. There we go. And you're like, oh my god, that's a lot of terms.
Good morning, Lumber Head School Principal. Good morning, take a moment.
Are we unpaused? I think we're unpaused. Alright. I sound like I know what I'm doing. Y'all see there's a 5x squared here minus a 5x. I'm telling you, these things have to cancel. If they're not canceling, you missed a parenthesis or something like that, okay? That's all. Go back, check. 5x squareds cancel. Ha 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 ha. 10xh isn't going to cancel out. It's got an h. You can look. It's not going to happen. 5h squared. It has an h with it. That's not going to cancel. Minus 3x. Oh, there's plus 3x. They cancel out. Goodbye. Minus 3h is another term. This is chilling there, right? And then plus 6 minus 6. They cancel out. Okay? And like I did last time, if you felt the inclination, you could factor an h out of what's left. You see everything up there has an h left, right? But when you're dividing all these terms by h, they teach you multiplication distributes, division distributes. You're just dividing h into all those things. So h is going to divide into here, into here, into here. Okay? That will leave me with 10x plus 5h minus 3. Aha. Okay? We divided an h out of all that junk. And if h is approaching 0, then 5h is approaching 0. So this is just 10x minus 3. And again, the reason why there's an x in our answer is because this is a formula for the slope at any x value. Okay? Questions? You ready? What's the slope of this function at x equals 1? 7. That's this right here. Yeah? Cool. Okay. All right. 2 more. Here we go. 3 over x plus 2. We're going to do this one right here. Okay, ready? 3 over x plus 2. That looks like this. Aha. The limit as h approaches 0 of 3. Yo, who won the football game last night? Does anybody know that?
We did.
No, I know Long Reach won.
Never mind. That was the last night.
The Ravens? They won.
No, I know the Ravens won. Who won last night? Sunday night. Buccaneers played the Patriots. That was a big game. The Bucks won. You guys didn't watch the Sunday night game?
I was working.
I know. I went to bed. I was working too, and then I went to bed. I watched the Ravens. Okay, go Ravens. I watched some of the Ravens. Anyway, here's the complex fraction. We're going to get rid of that complex fraction by multiplying by x plus h plus 2. Oh, come on, OneNote. If anyone from Microsoft is watching this video, this is what OneNote does to me. Huh? No, it's not. No, that's the Surface 7, man. Surface Pro 7. It's their flagship laptop. Okay. Here we go. We're just hanging out here in the portable, doing math. Ending task on OneNote. There we are. We're still recording. Excellent. So, man, I've changed all the settings in here. I don't know. Maybe I got too much going on for OneNote to handle. You can't handle this math. Anyway. Over. Here we go. This is what's happening. Wow. Right? Right. We're going to cancel out those denominators because we don't like those. We don't want complex fractions. We don't want things to be complex. We're distributing this to here. That's going to leave me with a 3 on top and an x plus 2 right here. That's what happens when you multiply those out, right? The x plus h plus 2 cancels. When I multiply these two here, that leaves me with a 3 and an x plus h plus 2. Which on the bottom, we have an h and an x plus h plus 2 and an x plus 2. Yeah, good. Yeah, awesome. And up top, just because I don't feel like writing this all out, like you should write another step here. But this is 3x minus 6. This is minus 3x minus 3h minus 6. Y'all see what happened there? That's what that is. So what's really left up top? The 3x's cancel. The 6 cancels. The only thing left is negative 3h. There we are. And now because we have multiplication, we can cancel out those h's. Okay? Goodbye h's. It was nice knowing you. You got to cancel them out, and then you plug in 0. If you try to plug in 0 before you cancel out any of these h's, you're going to get 0 over 0 every single time. Okay? But now when you plug 0 in for h, you get negative 3 over x plus 2 times x plus 2, but everybody knows that's just x plus 2 squared. And you can leave it like that. That's super nice. That's how we want it. And all this does is tell me the slope of 1 over, or 3 over, whatever, 2x, 3 over x plus 2. There we go. Okay? And you're right, number 6 is like just a completely useless, not useless question. You already know the answer to number 6. Guys, look at number 6. We're going to use the derivative here, okay? We're going to find the slope, a formula for the slope. What's the slope of that thing everywhere? 6, yes. Oh my God, resounding. I blew my microphone out with all that noise you guys made there, okay? Yeah, 6. Okay? So if we use this derivative thing, our answer will just be 6. That's what's going to happen. The reason why our answer was not a number for any of the others is because their slopes are changing. Their slope is dictated by the x value. You need to know what x value you are at which you are, I don't know. Plug it in to find the slope, okay? But when we do this one, this is easy, ready? This is number 6. It's just 6, that x becomes an x plus h, minus parentheses, the quantity, 6x plus 1 over h. Oh my goodness, look what happens. This is just 6x plus 6h plus 1 minus 6x minus 1. Okay, that's all that becomes. So this is just the limit as h goes to 0. Look what's left, 6h over h. Okay? Those h's cancel out. Goodbye, h's. And the only thing left to plug into is nothing. There's no h's left, so you don't plug in 0 at all. This is just 6. Haha, like we expected. Okay? Good talk.